How are you all? I hope you all are well. So today we are going to discuss the last topic of our chapter from grade 12, that is solid state. So we are coming to the end of this chapter. So today we are going to discuss about the magnetic properties of the solid. Now one more thing I want to tell you that in the previous video we have already discussed about the electrical properties of the solid. So if you want to see that, if you haven't seen that video, you can just click on the I button and just see that. Now after, when I am going to end this video, I am going to give you some questions related to this chapter, which is very important. So go through those questions and try to solve it. Okay, so let's begin. Now today we are going to discuss about the magnetic properties of the solid. Okay, like electrical properties, the solids are also having the magnetic properties of the solids. Now the question arises, why these property, that is the magnetic property, belongs to the solid, or why the magnetic property exists in the solid. Now the cause of magnetism is because of only one reason, that is the movement of electron in an atom. Okay, the electrons which are present in an atom, their movement results in the magnetic properties of the solid. How? Now we know that electrons used to revolve around the nucleus of an atom. Okay, so electron used to revolve around the nucleus of an atom, that is one thing, but electrons tends to move on its own axis also, like Earth. Okay, so electron tends to move on its own axis also, which is also known as the spin of the electron. But the thing is, unlike Earth, they spin in both direction, that is clockwise as well as anti-clockwise. Okay, so they are going to spin in both direction. So it means, if suppose as you have already discussed in the orbital, we used to set two electrons in a orbital. So both the electrons which we kept are of opposite spin, because one is going to one is going to spin in clockwise direction, while other is going to spin in anti-clockwise direction. So because of this movement of the electrons in the in its own axis and around the nucleus of an atom, they generate an electric field. Okay, just like an electric current, they used to create a loop. Okay, and because of this loop they generate a magnetic dipole. Okay, so because of this movement of the electron, a magnetic dipole movement is going to be created in the around the electrons. So each electron will exert the magnetic properties in the solid. So the magnetic properties of the solid is due to the movement of these electrons in an atom. Okay, now how many these type of electrons are there and how they are going to spin, on the basis of that different type of the magnetic substance are there. But the main reason is that when electrons are going to move on its own axis and around the nucleus of an atom, and they are going to spin in both direction, that is clockwise as well as anti-clockwise, they generate an electric field around them, and because of that a magnetic properties will be induced in any solid. So that is the reason of the magnetic properties in the solid. That is one thing. Now on the basis of the arrangement of the electrons and the type of the electrons which are present in the different type of the solids, we have different type of the magnetic substance. So first magnetic substance which is there is paramagnetic, second is diamagnetic, third is ferromagnetic, fourth is anti-ferromagnetic, and last is ferromagnetic substance. So these are basically 5 types of the magnetic substance we have. So we are going to discuss one by one. So first thing is paramagnetic substance. Now what is this paramagnetic substance? When we go through the definition, according to definition, paramagnetic substance are those which are weakly attracted. They are weakly attracted when placed in external magnetic field. Suppose we apply an external magnetic field around such kind of a solid which are paramagnetic, so they are going to be weakly attracted. Okay, means they will also have some magnetism on them, but very weak. So they are going to be weakly attracted. Such type of magnets are acting as a weak magnet and once the electric field is applied, then only they will be having those property, and their direction will be in the magnetic field direction. Means the whatever the direction we have applied as the external magnetic field, the same direction their particles are also going to be aligned, and they will be having some magnetic properties. Okay, but the problem is, once you take out that magnetic field, if you take out that magnetic field, that is external magnetic field, they will lose the magnetic property. Okay, so it means their magnetic property will remain there only till you are applying the external magnetic field. So they are only temporary magnet, or their magnetism is not going to be permanent. Okay, now we can classify such type of the substance by knowing the number of unpaired electron on them. If any substance is having unpaired electron, when we are saying unpaired electron in what? Unpaired electron in their orbital. Okay, as you have seen in grade 11. Unpaired electron in an orbital, then such substance are said to be paramagnetic substance. Okay, and this property of applying the external magnetic field and they are getting magnetized will be belonging to them. Only when you apply external magnetic field, they will show the magnetic property, and that is also weakly attracted in the magnetic field, and they will be having definitely at least one unpaired electron in their orbital. If the number of unpaired electrons are going to increase, their magnetic property will also increase. Okay, so that depend upon the number of unpaired electrons. So if you remember that if we have to compare the suppose different type of the magnetic substance, paramagnetic substance is there, and you want to compare that which is more paramagnetic or which is less, then you must know that how many unpaired electrons they are having, and you can calculate its magnetic moment. If you remember, one formula was there which we have done in grade 11, that is mu is equal to n plus 2. Okay, square root of under root of n plus 2. So where n means the number of unpaired electrons. So if you know the number of unpaired electrons, you can calculate its magnetic moment, and the value of the magnetic moment will be help you to compare the different type of paramagnetic substance, that is which is more paramagnetic or which is less paramagnetic. Okay, the example of such type of paramagnetic substance is like O2 or Cu2 plus. These are the examples. These substances are said to be the paramagnetic substance. Okay, now we come to the diamagnetic substance. Now diamagnetic substances are actually altogether opposite of paramagnetic. Okay, so you can memorize it like that. Whatever the properties the paramagnetic are having, opposite to that the property of diamagnetic will be having. That is, like they are weakly attracted in the external magnetic field, so they are going to be weakly repelled. Okay, they are going to be weakly repelled in the magnetic field. If these kind of substance are applied with the external magnetic field, then what is going to happen in the diamagnetic substance? They are going to align in opposite to the direction of the magnetic field. Whatever the direction of the magnetic field is there, they are having the opposite to that direction. That's why there will be no magnetic property exerted by them. So they are weakly repelled in the magnetic field. Okay, and such kind of substance will be having no unpaired electron. Unlike paramagnetic, they are having at least one unpaired electron. They will be having no unpaired electron. Okay, so their orbital will be having no unpaired electron. Okay, no unpaired electron means that all the electrons which are present in the orbitals are paired of opposite direction, like one is of clockwise, other is of anti-clockwise. So because of that, these properties belong to the diamagnetic substance. Okay, now diamagnetic substance can be like NaCl, we have like benzene also. These all are diamagnetic substance. Okay, so that is how we classify the paramagnetic and diamagnetic substance. Now we move to the other part, that is ferromagnetic substance. Now before we are going to study about ferromagnetic, antiferro and ferrimagnetic, you must understand about the one important factor that is known as domains. Now actually we classify these type of the magnetic substance on the basis of the domains. Now what are these domains? Actually these type of the substance, that is ferromagnetic, antiferromagnetic or ferrimagnetic, are basically a transition metals, And in transition metals, we used to say that in a transition element, the magnetic ions are going to be there present. Magnetic ion means, suppose if iron is there, then iron will be existing as Fe2 plus, ferrous ion. Okay. If manganese is there, then manganese will be existing as Mn2 plus ion, and the electrons will be there because they are going to lose electron. That's kind of a metallic bonding used to exist between them. The electrons are going to be there and the positive charge ions are going to be present there. So each ion which is present there will act as a tiny magnet. Each ion which is present over there act as a tiny magnet. Okay. So each ion which represent it as a tiny magnet are known as domains. Okay. Now these domains may have a same direction, may have opposite direction, means like positive negative direction we are having. So maybe all these domain will be having or aligned in a same direction, or maybe they can align in opposite direction. Okay. And on the basis of the direction in which they are aligned, they are classified as ferromagnetic, antiferromagnetic and ferrimagnetic substance. Okay. Now when we are saying aligned in the same direction, we are comparing it with the external magnetic field applied. Like suppose if ferromagnetic substance is there and I am representing these are the domains, okay, in form of arrow. These are suppose our domains, that is a tiny magnetic ion, they are known as domains. So if we apply external magnetic field in a ferromagnetic substance, then what is going to happen? All these domains will be having same direction. They will align themselves in the same direction, due to which they are going to be strongly attracted in the magnetic field. They are strongly attracted in the magnetic field, and even then if you take out that external magnetic field, their magnetic properties will be remaining there only. Means they will become permanent magnet. They will be having the property of permanent magnet because all the domains will be aligning in the same direction, so which create a strong magnetic field. Okay. So they are basically acting as a permanent magnet, because when once you take out the magnetic field, then also they will be behaving as a magnet. Okay. So they are termed as ferromagnetic substance. Now ferromagnetic substance, like we have chromium oxides of chromium, we can have cobalt, we can have nickel. All these are the examples of the ferromagnetic substance. Okay. So our ferromagnetic substance are actual permanent magnet which we used to see, okay, in nature. Now the next one is antiferro. As the name is suggesting, anti means opposite. So whatever the property ferromagnetic is exhibiting, opposite to that the antiferro is going to exhibit. So you can memorize it like this, like paramagnetic, whatever the property is having, diamagnetic will be having opposite to that. Okay. Same, but example you must remember. Ferromagnetic, whatever the property is having, antiferro will be having opposite to that. So what is going to happen here? Here also the domains will be present. Okay. Suppose these are the domains, but they will align themselves in the opposite direction in equal number. Like suppose I have shown you 4 domains here. Now out of 4 domains, 2 domains are having one direction and others will be having opposite direction to that. Okay. So these 2 are having opposite direction to these 2. So when they are having opposite direction, they are going to cancel each other effect, and when they cancel each other effect, now what is going to happen? Actually the magnetic property will not be shown by that type of the solid. Means they are having magnetic properties, but it cannot exhibit those magnetic properties like ferromagnetic substance, because their magnetic properties are cancelled by each other domains. As they are aligned in the opposite direction, they are cancelling each other effect. Okay. So such substances are known as antiferromagnetic substance. Okay. Like the oxides of nickel NiO will be an antiferromagnetic substance. So you can see, if you study about the ferromagnetics, then opposite to that the property belongs to the antiferro. Here the domains are there, but they are aligned in the opposite direction and they are cancelling each other effect. Now we come to the last part, that is known as ferrimagnetic substance. Now what is this ferrimagnetic substance? Ferrimagnetic substance are those where domains are there. Like suppose there are 4 domains. Okay. One domain is in this direction, another domain is in this direction, one more domain is in the same direction, but one domain is in opposite direction. So what is happening here? Domains are in opposite direction here also, like anti-ferro, but their number is unequal. It means some net magnetic dipole moment will be there. Okay, means the opposite opposite domains are going to be there, but their number are unequal, so they cannot cancel each other totally. So there will be some magnetic properties which is going to be left in such kind of a solid. So such type of the magnetic substance are known as ferromagnetic substance. Okay, ferrites of magnetites, okay, will be having such kind of the properties, that is they are basically known as ferromagnetic substance. Ferrites or magnetites, like we have example also, Fe3O4 will be a ferromagnetic substance. Okay, so like that we have the magnetic properties. A quick revision: cause of magnetism is due to the movement of the electron, okay, which create the electric field, and the magnetic property will be there. Classification is there: paramagnetic, diamagnetic, ferromagnetic, antiferro, ferri. Paramagnetic, weakly attracted in magnetic field, will lose the magnetic property if the magnetic field will be taken out. They will be having definitely unpaired electron present in their orbital. Their magnetic movement can be, their magnetic behavior basically can be compared by using this formula, where n is number of unpaired electron. Diamagnetic substance, weakly repelled in the magnetic field. There is no unpaired electron present in the diamagnetic substance, opposite to that of paramagnetic, and hence they will not show any magnetic properties. Now ferromagnetic substance, basically the transition metals we are talking about, they will be having there the ions, that is a magnet, the metal ions existing as a tiny magnet, and they are known as domains. If their domains are in the same direction of the magnetic field, then they are strongly attracted in the magnetic field and may become permanent magnet, and they are known as ferromagnetic. Antiferro, opposite to that, where the domains are there but they are aligned in the opposite direction, so they are cancelling each other effect, and that is also in equal number, that's why totally cancelled. In ferromagnetic substance, domains may be in opposite direction but not in equal number, so there will be some net magnetic property belong to that substance. So that is how we classified all these type of the magnetic properties in the solid. So now, dear students, the chapter is over. Okay, this chapter is finished. So if you have not seen the previous videos, you can go through my channel and see all the videos. Okay, and you can also click on the link which is given on the description to see the important questions. Okay, I am going to give you some important questions, so just go through that link and solve all those questions, try to solve it, and it will help you a lot. Okay, so today we are finishing with this chapter. Now after this, when we are going to come again, we are going to start the next chapter. Okay, so like my channel, subscribe it, and press the bell icon, and see you in the next video. Okay.